Welcome to EDU World Space.
So we have three charges which are placed at the corners of this equilateral triangle. So let's say we have 7 microcoulomb here, minus 8 microcoulomb here, and minus 6 microcoulomb here. And let us say that this equilateral triangle has the side length of 1.2 meters. So since this is equilateral, all the sides will be equal. And we will find out the magnitude and direction of the force at each of these charges. So let us start with the force at this 7 microcoulomb. So here that is A. So force on 7 microcoulomb charge. So this is negative. One force will be in this direction, another force will be in this direction, and the angle is 60 degree. So the direction is going to be somewhat in this. So we will figure out that direction also. So this is a vector. Let us say this force due to 7 and minus 8, that will be k q1 q2 by r square, that is 1.2 whole square. So we get this as 56 k by 1.44, and this comes out to be 5600 by 144, and this will be 25k. So this force comes out to be 25k. So let us just write them shortly. Also, we will take the units into consideration. So let us say we name it as F1 and F2, and let's find out F1 here. So F1 will be K Q1 Q2. So these are in microcoulombs, so it will be, let's write the value of K as well. So K will be 9 into 10 to power 9, Q1 into Q2. So it will be 56 into 10 to power minus 12 by R square, that is 1.44 over here. And if we simplify, we get 3.5 into 10 to power minus 1. So that is 0.35 newtons we get. Similarly, F2 will be K Q1 Q2, that is 7 into 6, so 42 into 10 to power minus 12 by 1.2 whole square. So if we simplify this, we get 262 or 0.26 times, or this much Newton. Yeah, this much Newton. So if we want to find out the net force will be, the magnitude of net will be the resultant of these two forces, and we have the angle between them as 60. So it will be root of f1 squared, so 0.35 squared, plus f2 squared, that is 0.26 squared, plus 2 times f1 into f2 times cos 60, that is 1 by 2. So this gets cut here. So if we simplify this, so we take the square of 0.35 and add it with the square of 0.26, and then we add it with the multiplication of 0.35 and 0.26. So we take the root, we get 0.53 newtons. This is the magnitude of net force acting on this 7 microcoulomb. Talking about its direction, so angle will be tan inverse. Let's take either of the force. Let's say I take this F1. So 0.35 sine 60 degree, that is root 3 by 2 over 0.26 plus 0.35 times cos 60, that is 1 by 2. So this comes out to be, let us simplify this one. So root 3 will take approximately 1.732, and taking the tan inverse of this, we get the angle as 0.66. That's 66. So let us first find out this simplified form. So tan inverse 0.35 times 1.732 over 2. This comes out to be zero point 0.3 approximately, and we divide it by 0.35 by 2 plus 0.26, that is 0.42 approx. So when we divide zero point 0.3 by 0.42, we get 0.71, and we take the tan inverse of this, and this gives us approximately 35 degree. This is an approximate result. So basically this total angle is 60 degree, and we have got this angle as 35. That means we can say the magnitude will be what we found here as 0.53 Newton, and in the direction of 35 degree with respect to this edge. Similarly, we will find the net force on this minus 8 microcoulomb and minus 6 microcoulomb. So one of them let us do. Let's say we will find magnitude of the force here. So on minus 8, one force will be in this direction and one force will be in this direction because they both are like charges. So this force will be K Q1 Q2. So that will be 56 over R square. So we are actually doing in terms of magnitude the same thing. So it will be 0.35 Newton in this, and this force will be this force will be zero point 0.9 into 10 to power 9 into 8 times 6 into 10 to power minus 12 by 1.44. So if we simplify this, we're gonna get 9 times 48 over 1.44. That is zero point 0.3 newtons. So we have one force in this direction with 0.35 Newton, another force in this direction with 0.3 Newton, and the angle is 120. So now we can find out the magnitude of the force. So we'll apply the same procedure here. So it will be root of 0.3 square plus 0.35 squared plus 2 times the product of these two force, and cos 120, that will be minus 1 by 2. So when we simplify this, we're gonna get 0.35 per times 0.3. So we get finally 1.1075, and root of this will be 0.32 newtons approximately. And the direction again we can get using that same procedure. So alpha will be tan inverse 0.35 sine 120 over 0.3 plus 0.35 cos 120. So taking this value, we get the value that 0.35 sine 120, we can write it as sine 60. So 0.35 times 1.732 by 2. We get zero point 0.3 again. And in the denominator, we have 0.47 again. So this again comes out to be roughly 35 degree. So this will be the direction of the resultant force, and this will be 35 degree approx. And same thing we can apply even for the force on this. Only thing is that in this direction there will be force due to minus 8 and minus 6, and that force will be the same magnitude here, so 0.3 Newton. And this force will be between 6 and 7. So between 6 and 7 we have already figured out here. Between 6 and 7, yes, we figured out here. This was 0.26 Newton. So now our situation simplifies to a force here with 0.26 Newton and another force here with magnitude 0.3 Newton, and the angle is 120. So we find the net force here again by using the expression for the net magnitude of the vectors. So 0.26 squared plus zero point 0.3 squared plus 2 times 0.26 times 0.3 times cos 120, that is minus 1 by 2. So this will come out to be, so if we do 0.26 squared and add it with 0.09 because that's the square of zero point 0.3. This comes out to be 0.0796 and root we get 0.28 newtons approx. And again, to find the direction, let us say the direction is alpha here. So alpha will be tan inverse 0.26 times sine 120 over zero point 0.3 plus 0.26 times cos 120. This is the expression to get the direction. So we get this as, let's put this here, sine 120 we'll take sine 60, that is root 3 by 2, and root 3 we will take it as 1.732. So we get here 0.22, and in the denominator we get here 0.17. This is 0.17, and here we find the tan inverse of 0.22 over 0.17. Taking the tan inverse, we get approximately 52 degree. That means the direction will be at 52 degree with respect to zero point 0.3 Newton force, and the magnitude will be 0.28 newtons.